So the first orientation change is the RPY angles, or what is called as roll, pitch, yaw. R stands for roll, P for pitch, and Y for yaw. I have already previously taken in one of the classes what is the movement of roll, pitch, and yaw. Well, in our case, what we are talking about is, suppose that there is a frame that is at this particular position. We don't know what is the position. Let's say it's some position P. Now this is the n axis parallel to x. This is the n parallel to x, O parallel to y, and A parallel to z axis. This is the NOA. And the first movement is that we give a turn, an anti-clockwise turn, when looking from A direction. So when we do that, what happens? The n gets turned here by some angle. Let us name that angle as phi A. So this angle is phi A. So I will write that. So that angle is phi A. Similarly, O also will get shifted by that much. So let me draw it as dotted. So this is now the new N and this is the new O. This is the new N and this is the new O. Why? Because we have shifted we have rotated. So that is the first sequence. So the first sequence we will write it as rotation with respect to A axis phi A angle. And this is actually what is called as the roll. Okay, this is the roll movement. With respect to A, we have to rotate in anti-clockwise direction, an angle of phi A. Next, so the next one we will draw, because after this movement, as I have drawn here, the NOA axis are now not parallel to X. So the N is here, the O is here, and A is still here. A is still parallel to Z, N is not parallel to X, O is not parallel to Y. Okay. The next movement is that we are going to pitch it. Pitch it means we are going to rotate anti-clockwise direction with respect to O. So with respect to O, so if I am looking from this direction, then O axis, this is the anti-clockwise movement, and with that movement A will come in, let's say I have touched it, let's say it is moved and has come here, and similarly N has also turned and it has come here. Okay, so that angle is, let's say that angle is phi N, phi O, because we are moving with respect to O, so it is going to be phi O. So this is your new A and this is going to be your new N, and this is O. So this is the second movement. So this one we will write it as rotation with respect to O axis with an angle of phi O, and this is called as pitch. And the third one is, so see, we have not changed the position is remaining the same, only the orientation is changing. The third one, so we will have to first draw the, what do you say, the first NOA, the current condition of NOA. So O is here. Okay, let me try to draw it. A is now here. Based on this diagram I am drawing, the second diagram. Okay, and N is right now here. So now everything has oriented in a different direction. The third movement is with respect to the N axis, and so with respect to N axis we are going to rotate in this direction. So when I rotate like that, O will move a certain angle, A will also move a certain angle, So let me draw that angle. A will suppose move here. So this is going to be the new A. This is going to be the new O. So this is the angle that A has moved, and let that angle be phi. Phi with respect to n I have moved, so it is going to be phi n. So after these three movements, so the last movement is rotation with respect to n axis, an angle of phi n. This is called as yaw. So after this raw pitch yaw, what will be the equation of the orientation B? See, here we have already started with orientation being n being parallel to x, O being parallel to y, and A being parallel to z. But after these three rotation motion of the wrist, the orientation has right now changed. And with this three motion, we can achieve any kind of orientation that we want. That is RPY angle, and based on that we have to find out the kinetic equation. The kinetic equation we can directly say, so let me write it. So the RPY orientation equation, kinetic equation, kinematic equation can be written with respect to the three angular movement of phi A, phi O, and phi N, which is based on these three motions that we have just now studied. So all these with respect to A, with respect to O, with respect to N, all of these are based on the frame. So here we have to use post multiplication. So the equation will come out to be that first, it's in the sequence itself. So rotation with respect to A, phi A angle multiplied with rotation with respect to O of phi O angle, and third is rotation with respect to N of phi N angle. Now we can write for each of these three equations, we can write the 4x4 dimension kinematic equation, that means the transformation matrix we can write, and we have to multiply. I'm not going to write the individual matrix of each of this one. You can write it on your own. That means you can write what is rotation A, phi A, because we have already studied that. You will get 3 4x4 matrix. The multiplication of that will lead to an equation which can be written as this. So it is cos of phi A, cos of phi naught, phi O, sorry, sine of phi A, cos of phi O, minus sine of phi O, 0. Similarly, the second one, third column, and finally the position column. You can see the position has not changed. That's why the position is shown as 0, 0, 0 with a scaling factor of 1. So this is the RPY sequence or RPY angles, and as I have already told, the sequence of rotation, you should not forget the sequence. First is roll, then pitch, then yaw, and we have to draw this diagram. Okay, so this is one of the methods in which we can orient the wrist in any particular angle. Now if suppose someone asks that I want that my wrist must be oriented in such and such direction, we can solve these equations to actually find out the angles of rotation, which are phi A, phi naught, and phi n. But since that is not there as a portion in your syllabus, I will not take that here.